Nomenclature is something that we use in chemistry for naming compounds and writing chemical formulas. So to do this, we're going to break our periodic table in 5 different categories. And I'm going to call it type 1 through 5. So if you have your periodic table, you should color code it just like how I do it here. So type 1 are all the compounds that start with everything in column 1 except hydrogen, everything in column 2, silver, zinc, aluminum, gallium, and indium. So if you have a compound that starts with any of the purple ones, we call it type 1 compound. Type 2 compounds are any compound that starts with any of the oranges. So those are type 2. So mostly they're transition metals and inner transition. Type 3 compounds are the ones that start with the light blue color elements, and they're all on the right side of the periodic table to the right of the stairs. Don't forget that stairs are a division between metals and non-metal. Everything to the left are metals and everything to the right are non-metals. And type 4 is not on the periodic table. Type 4 are polyatomics, and you should have memorized them. Type 5 compound are everything that starts with hydrogen only. So those are the general 5 types. So we're going to talk about each type individually. Let's look at some definitions first. So cation is anything that has a positive charge ion, such as ammonium, calcium. Anything that has a positive ions, we call it cation. And anything with a negative ions, we're going to call it anion. So there are some charges that I like to mention. So I'm going to go back to the periodic table one more time. So everything in column 1 would be a positive 1. So you guys can go ahead and mark that on top of column 1 on the periodic table. You can put a +1 on top of column 1. And then everything in column 2 are positive 2. So go ahead and put positive 2 on top of column 2. Now I'm going to move to the right. Nothing for the noble gases, so 0 on top of the helium, neon, argon. So everything in the right column is 0 charge. And next to that, we have fluorine, chlorine, bromine, iodine. Those are the halogens. Would you please put a would you please put a -1 charge on top of that column? Oxygen column will be a -2. Nitrogen column will be a -3. All right, and then we have aluminum, +3. Just go ahead and write it in the box. So +3, gallium is +3, indium is +3, zinc is a +2, silver is a +1. Those are the charges that we know. Everything else, we're going to have to figure out doing a little math, and I'll show you how to do that later. All right, so we're going to go back to the notes again. So again, cations, anything with a positive charge. Anions, anything with a negative charge. Binary compound. Binary means 2. So binary compound are the compounds that compose of 2 elements. Binary ionic compound. So again, binary means 2, but whenever you have an ionic compound, you'll have a compound that is composed of metal and a non-metal. Metals are all cation because they're all positive charge. Anions are the non-metals. So binary ionic compound has a metal and a non-metal. And you should know where they are on the periodic table already. This stairs divides the metals from non-metal. Left metal, right non-metal. Okay, now let's talk about type 1. So type 1 is when we have cations always have the same charge. So you have color-coded periodic table already. Everything that were purple on my periodic table, everything that were purple are type 1. So if you have any compound that starts with purple, you know it's type 1. All right, so the rules for naming type 1. We name the cation first, anion second. For the name of the cation, the name for that will stay the same. So calcium is calcium, sodium is sodium. But for the name of the anion, we're going to change it to IDE ending. So chlorine becomes chlorine becomes chloride, oxygen becomes oxide, nitrogen becomes nitride. So anything anion for type 1, you're going to have to change it to IDE ending. Okay, I have some examples here. 4 examples. NaCl, let's start with that. Na, so if you look it up on the periodic table, it should tell you that Na is the type 1. You just have to check the first element. And get in the habit of checking every time because we're going to have 5 types by the end of the chapter. And to avoid getting them mixed up, you should check what kind of type you have first. So just check the first element. Na is type 1 element. So we're going to name it using type 1 rule. All right, so to name that, we're going to name the first element as is. So Na will be sodium. And then Cl is chlorine. We're going to change the ending to chloride. So that'll be sodium chloride. Okay, let's try the next one. Ki. So again, check your periodic table. So K is the purple one. So that tells me it's a type 1. So I'm going to name it using type 1 rule. So K is potassium. We don't change the word for the first element. So K is potassium. And then iodine becomes iodide. All right. Now for AlCO3. Al, let's check again. Periodic table. Al is right over here, another purple. So that's type 1. So I'm going to name as is. Al is aluminum. And then Cl, we're going to call it chlorine. Please do not name the numbers. Name those little numbers for type 1. It says, for the rules for naming, it says nothing about naming the little numbers on the bottom. So never name this as aluminum trichloride, just aluminum chloride for type 1. All right, same thing for MgBr2. So Mg, let's just check. Mg, purple. So that is a type 1. So we're going to name Mg as magnesium. And Br is bromine. I'm going to change it to bromide. Again, don't name the little number for type 1. So just aluminum bromide. Okay, so that is it for type 1. It's pretty easy as long as you know, you remember to check for a type 1 compound. So type 1 compound has their own rules for naming, and then also same for the formulas. Okay, so now that we know how to name, how do we do this backwards? So if I give you the name, how would you write the formula? The rules for writing formula is right here. All right, rules for naming formula says that we have to balance the charges. Right, now the way we balance the charges is that we take the charges. So for example, sodium is Na with a positive 1 charge. And then bromide is Br with a negative 1 charge. Okay, so we take the charges and then we're going to switch them to the bottom because normally charges are on the top. I can't do superscript with this application. So we're going to write it as Na plus 1, Br minus 1. So we're going to take the numbers and then we're going to switch it and bring it to the bottom to make it into subscript. So I will have, so this turns out to be Na 1 on the bottom, Br 1 on the bottom. But normally we don't write the 1 on the bottom, so we're just going to name it as NaBr. Okay, let's try the next one. Magnesium chloride. So if you remember to look it up on your periodic table, magnesium is Mg with a positive 2 charge. So again, charges normally go on the top right. So with this application, I'm going to write it next to it since I can't do superscript here. So Mg is positive 2. And then chloride, the Cl with a minus 1 charge. All right, so we're going to take the number. We drop the sign. We just take the numbers and switch them, bring it to the bottom to make it into a superscript. So I have MG1 and then CL2. So this 2 should be on the bottom as a subscript. All right, let's try the next one. Aluminum oxide. Aluminum is Al with a positive 3 charge, and then oxide is O with a negative 2 charge. So when we take the numbers and switch them to the bottom, it becomes Al2O3. And again, write the 2 and 3 on the bottom for our subscript. Magnesium oxide is the next one. Magnesium is Mg with a positive 2 charge, and then oxide is O, negative 2 charge. Okay, so when I take the 2 and the 2 and cross them over to bring it to the bottom, I still have 2 and 2. So whenever we have a subscript that can be reduced, we have to reduce it down. So this is what I have at first, Mg2O2, and I'm going to reduce down to MgO. Okay, so that is the type 1.